a good morning, good afternoon, or good evening, whatever may you be your case. We are looking at the resonance. Resonance. What is this? That all bodies have naturally frequencies. Okay? If it is a guitar string, it has a particular frequency. When does it produce sound? When you perturb it. When you perturb the guitar string. If it's a drum, when somebody plays the drum, that skin has a particular frequency. If it's a door, it has a particular frequency. If it's a window, it has a particular frequency. If it's a building, it has a particular frequency. So that building will produce some sound when it is disturbed. When you perturb it, it will certainly produce some sound. But then there is a case where a particular system or object is made to produce sound when actually you're not perturbing it physically, but there is some spiritual perturbation, if I may say. In a case that perturbation is, then that body will vibrate at its original frequency due to the vibration of another nearby body at the same frequency. So, but this one leads us to pipes and tubes. And so, with me is a decoder. So this is a decoder. It is open at both ends. But I would certainly want to enlighten you about the closed pipes. Take an example. We simply have this kind of a pipe. When you blow in air, it goes, then when it reaches the bottom, it is reflected. Okay? So if I begin with my original assumption that air starts from there, so therefore, if this is the length of the pipe, okay, then we want to look at this one in terms of wavelength. We have all seen this, that if I'm looking at wavelength, if I have this, see from here to here is the wavelength, right? But when you look at this kind of a section, this section here is similar to this section that ends here. You see, this is a half wavelength, meaning this is a quarter wavelength. Because you can see this section, if I may actually pull it out, it will just be like this one, right? Which is actually the same as this one. Therefore, what does this give us? This gives us this length L. It gives us this length L equals to the wavelength out of 4 becomes a quarter wavelength. And in this case, if we wanted now the wavelength for that kind of vibration, if I multiply this one here, it will simply become 4L. But then what are we interested in? We are interested in the frequency of this, which is actually the fundamental frequency, the smallest frequency this system can vibrate with, the smallest frequency this tube could give us. And therefore, from the wave equation we are used of this one, yes, V equals lambda F. F is V of lambda. And therefore, the fundamental frequency here, in this case, fundamental frequency F naught is V, then is V, then lambda, which is wavelength, is this one, out of 4L. That would be our fundamental frequency, the smallest frequency this one could vibrate with. A very big point of concern. But this is not the only case. There are also other cases where I could be having the same kind of a pipe, but then the vibration takes it to another level. So it comes like this, then of course when it is reflected, it will have to come and it will be like that. So you can see that as we did in the first case, this one was a quarter of the wavelength, and now this is a quarter here, this another quarter, another quarter. Therefore, this length L would be given 3/4 of wavelength. Therefore, our wavelength will become 4L out of 3. Now, if we certainly have this, what else do we have? Now, what is F1? The next frequency we can have would be V out of this. So when you divide by this, of course, when you divide by this, the 3 will be up, and then we shall have 4L. Now here, that is the second frequency that you can have. And you can see that F0 has 4L and F1 has 4L. So from equation 2, there is something I want to show you. I want to get equation 2 and divide by equation 1. So equation 2 is F1 equals 3V out of 4L. Then we are dividing by F0, which is equal to, now divide here by V out of 4L. And you know the mathematics that we have to use in such a case. So in such a case that we do have, we shall say F1 out of F0 is equivalent to 3V out of 4L. Then we shall multiply by the reciprocal of this, which is 4L out of V. And so the 4L will cancel, the V will cancel. So we shall have F1 out of F0 equal 3. Very interesting. Yes. So therefore, if I was multiply here, the F1 will simply become 3 F0. You keep this one. You keep this one because we shall certainly use it somewhere. I want to give you another case. Another case when we have now more vibrations than this one, meaning the same length, but now for another case, so I still have the same two, they are the same length. So another possible mode of vibration would be of this way. Yes, that would be the next possible mode of vibration. And we see that at any point, the wavelength keeps on reducing, meaning we should be having increasing frequency. So you can see this is a quarter, another quarter, the second one, the third one, the fourth one, and the fifth one. So therefore, the whole of this is the 5 quarters of the wavelength. But you're saying that this one is the air, is the length of this tube. So therefore, we say that L equals 5 out of 4 of this, which will certainly give us this equals 4L out of 5. Now, if it certainly gives us that, what will this one give us? That our next available frequency, F2, will become, as we have been saying, frequency V out of lambda. So it is V out of, now the wavelength, which is 4L out of 5. The 5 comes here. Yes. Now this is our F2. Now if this is our F2, we want to compare this F2 with our original F0. Yes. So therefore, we shall say that F2 out of F0 equals F2, which is 5V out of 4L. Then we are divided by F0. If you can remember our F0 from there, which is V out of 4L. Yes, V out of 4L. And then this one will give us 5V out of 4L. Then we multiply by the reciprocal like that. The 4L will go the view we go shall have F2 out of F0 equaling to, shall have it equaling to 5. Yes, so that's what of course we will have. Okay? Yeah, that's what you have got. So finally, we have F2 out of F0 equaling to 5, which gives us F2 equals 5 F0. What are you realizing? We are realizing that F0, we have F1, which is equal to F0. We are realizing that we have F2, which is equal to 5 F0. What do you think F3 will be equal to? That F3 that you have thought about is actually what it is. So F3 will certainly become 7 F0. F4 will certainly become 9 F0 and etc. And therefore, we are seeing our frequencies as the original one, of course, which is F0, the next 3 F0, the next 5 F0, the next 7 F0, the next 9 F0, the next, okay? You realize that we shall have 99 F0. What do you see? That originally I brought an instrument which is open at both ends. This is crossed. We are soon understanding why the instruments which are crossed at one end are not as good as the ones which are open at both ends, because this one produces only odd multiples of the fundamental frequency. Only F0, 3 F0, 5, 7, oh, this was 9, and 9 F0, and etc, etc. This is what we have. The next, you need to know what happens when I have an open pipe. I mean, the one open at both ends. Yours is to replay the video and have more understanding. Yes, MC course in class this time. We move. Take your time, look through and get applications of what you are studying. Thank you for paying attention to this. Please, it is necessary that you repray and pray and pray and pray until you are able to understand all this one. Watch out next for open pipes. Bye-bye.